Welcome to the third and final video for lesson 1. In this video we're going to quickly review what we mean by just converting in terms of linear motion, going from things like miles per hour to kilometers per second. And then at the end including the idea of angular motion, which is kind of doing the same thing but including the idea of revolutions per second or rotations per minute, things of that nature. We're going to start with a bit of a review problem. We just want to convert 65 miles per hour into feet per second. This is probably something you've been doing for quite a while, either in math classes or in especially probably science classes like physical science. I think you guys do a lot of this. We want to convert 65 miles per hour into feet per second. I like to show a lot of work in these kind of problems. I really want to see this in your own work as well. Show me the fractions and how you're crossing things off. I think that's going to be very beneficial to kind of verifying that you're doing things the right way. In this first problem, we start with 65 miles per hour per 1 hour, and your job is to convert the numerator into feet and the denominator into seconds as far as units go. We're going to do that by multiplying by a series of fractions that are in some ways equivalent to 1. If you multiply by 1, you're not really changing the idea. The fractions that we're going to use are things like 12 inches in 1 foot. They basically mean the same thing. I know that number-wise they're a little different, but the general idea is still they're equivalent, so it's like we're multiplying by 1. So you could start with either top or bottom. In this case, I'll just start with the top. 1 mile is equivalent to 5,280 feet. So I would multiply our original fraction by 5,280 feet over 1 mile. And the reason I do that is miles on top and miles on bottom cancel each other out. And so now my distance unit, my numerator unit, has now been converted into feet. My job is now to continue this work and convert the time from hours into seconds. Some of you might know a way to do this right away, but I think for most of us we're probably going to multiply by two quick simple fractions here. In 1 hour I know there are 60 minutes, so in this case I put 1 hour on top and 60 minutes on the bottom. And then I also know that in 1 minute there are 60 seconds. And the reason I order them this way is that I now have minutes on top and bottom. I have hours on top and on bottom. Let me scroll over here a second. And on bottom. Okay, so that will cancel off. And now if you look at my work, my units in the numerator are feet and the units in my denominator are seconds. And so now it's just a matter of simplifying the numbers that I see here. And that's not going to be too bad. If I were to multiply all the numbers in the numerator together, 65 times 5,280 times a 1 times a 1, I would get 343,200. So I'm just going to write that. I'm going to do this in two parts, a numerator and denominator part. So 343,200. And that unit for that would be feet. Okay, my denominator would be 1 times 1 times 60 times 60. That is 3,600. And that unit would be in seconds. Technically, I've kind of solved the question here just by doing that. But I want to simplify that a little bit more. I just want one number. So I'm actually going to divide those two. When I do that, I get 95.3 repeating. And my units for that would be feet per second. And that technically is the answer that I'm looking for in this question. In my mind, that's a little bit of review. We definitely will be doing some of those as practice, but hopefully that is something you remember doing in other classes. Okay, I would say the main thing that we're dealing with, or the main reason we're studying this, is for a question like example 2. When I was in college, I bought a Ford Focus. That was back in 2003, I believe. It was a fantastic car. I drove it all over the place. Sadly, I have sold it. I drive a minivan now. We're moving on up in the world. and Ford Focus wasn't cutting it. But I want you to picture this car having 36-inch diameter wheels, and I want you to envision me driving this maybe down Ivanrest. The tires are rotating at 630 revolutions per minute. I want you to find my speed in miles per hour. You think you can do that? I hope you can. This will be a more typical question of what we look for in our homework problems. Okay, so just like the previous one, we're going to start by writing out our first fraction, 630 revolutions in 1 minute. And I just need to multiply by a series of fractions that are going to, in the end, get me to miles per hour. I'm going to start with the time in this problem because that's going to be very quick. There are, let's see, we're going miles per hour, so there are 60 minutes in 1 hour. And that is a quick, easy way to cancel off the time. Right away, I have the correct time unit that I'm looking for. I have hours. I now need to consider how do I change this? What do I multiply by to get my numerator to go from revolutions to miles? And that's the tricky part here. So I want you to remember that in 1 revolution, let me get the pen here, and maybe let me undo that little mark. There we go. Okay. So in 1 revolution, we have already talked about in radian measure how many radians it takes to go all the way around a circle. So in 1 revolution, I already know there are 2 pi radians. And we need to remember, what is a radian? 1 radian is really just 1 radius of our circle. Okay, to me that's kind of the tricky part of what we're doing here, just kind of making that connection. That how do I include radians and then connect it to a radius within this work? Okay, my car has 36-inch diameter wheels. That means that the radius of those wheels is 18 inches. So I know that 1 radius is 18 inches. And now all of a sudden we are using units that deal with length. So maybe before I go too far, I should just cross off some units here so that you see where I'm going with this. Let's see, what do I have here? We have revolutions that will cancel off. We have radians that will cancel off. And we have radius that will cancel off. So now I'm in inches per hour. I'm really, really, really close. I just need to convert inches into miles. So how would I start doing that? I'm going to create a new line here. Get my right color again. Break the pen. That would be helpful. Okay. So there are 12 inches in 1 foot. And there are 5,280 feet in 1 mile. If I go through and kind of cancel off units again, the feet will cancel off, inches will cancel off, like so. And now if I look at all this work, I do have it in the correct sort of notation where in the end I have miles on the top, I have hours on the bottom. That's what I was looking for in the original question. Okay, so we need to do a little calculation here. Multiply all the numerators together. So I'm going to start with 630 times 60 times 2 pi times a 1 times an 18 times a 1 times a 1. And that gets me, oh boy, that's a big number. Let's see, 4,275,079.283, somewhere around there. And of course this would pop up here. Let me grab my mouse. There we go. Continue. Okay. So I have my numerator figured out. I'm going to divide by every number in the denominator. So I'm going to divide by a 1 and another 1 and another 1 and another 1 and another 1. Then divide by 12 and divide by 5,280. I go through all of that. I get 67.4 67.473. So it's going to equal 67.473, and that would be in miles per hour. Okay, so that's one way. I guess another big type of question that we want to look at for this section, just why are radians useful? They help us convert from ideas from like rotations per minute into inches per second. Just a useful way of thinking through a question like this. Definitely not the only way, but one thing that we want to consider. Jot down any questions that you might have, and we will see you in class.